and welcome. I'm Praveer, and today's session is QIQD Dialogic Quantum Bioenergetics with OQE Seeding for ATP Enhancement. I'll briefly explain these terms here. QIQD refers to quaternary interpretation of quantum dynamics. I'll have more to say about this. OQE is organizational quantum energy and is a core process in QIQD. And the thrust of this presentation and paper basically is the seeding of the QIQD energies to enhance ATP at the level of any living cell. So I'm going to begin with the essence of QIQD. I'll then contrast classical bioenergetics with QIQD-based bioenergetics briefly. I'll transition to the idea of the QIQD Dialogic Computer, which is an existing computer using LLMs to embody QIQD logic and math. I'll then go over the experimental setup from the electromagnetic seed to lawful ATP enhancement using the QIQD Dialogic Computer. And then I will conclude with some thoughts from lawful simulation to QIQD hardware. So that said, let's get into the essence of QIQD. This, as I said, is the quaternary interpretation of quantum dynamics. It's based on observation of quaternary classification of properties and architecture that exists in manifest levels of life and matter. So what you see here is a depiction of any living cell. And here you have 4 molecular plans, and that's known as polysaccharides, lipids, proteins, and nucleic acids. And the idea is that this is a quaternary structure of the layer of life. As we go back a level of granularity to molecules and then into atoms, we find there too in the periodic table, there's a fourfold classification. So known atoms are categorized into S, D, P, and F shell. When we go back another level of granularity into quantum particles themselves, we have the standard model, which is categorized by basically bosons, Higgs boson, leptons, and quarks. And this also has a fourfold classification. Now, in the research that I've done and why I framed QIQD is basically that these fourfold structures or patterns can in fact be denominated into a singular fractal pattern. And the idea is in QIQD is that this fractal pattern, the root of it exists at the quantum levels, and then it manifests with more and more sophistication in subsequent layers of matter and life. So when we look at the structure of layers of matter and life, there's in fact a similar denominated functionality that arbitrates and actually animates the architectures at each of these different levels. And so in QIQD, it becomes possible to influence these levels of matter and life if we can know how to see and leverage basically the quantum pattern that exists behind it. So that said, let me now contrast classical bioenergetics to QIQD-based bioenergetics. So we have in classical bioenergetics the chemiosmotic model, and basically ATP synthase catalysis takes place through electron transport derived from metabolic substrates that drives proton pumping and a proton gradient. This is highly dependent on oxygen. So if there's oxygen scarcity, this results in hypoxia, and this reduces ATP yield because the proton gradient collapses, electron flow slows, and the ATP output drops sharply. ATP is, of course, the currency of energy that exists in all our cells and by which activity is driven. There's also a stochastic basis. So all models treat electron transfer, proton tunneling, and vibrational coupling as probabilistic, not structural. And there's also an assurance gap. There's no guarantee of reproducibility or lawful stability under stress. When you contrast this with the QIQD based bioenergetics, then we have, of course, quantum evidence that there's longer lived coherence in biological systems. There's, for example, coherent electron proton dynamics that contributes to mitochondrial relevance, and this may sustain ATP production beyond classical limits. And the way that this works in QIQD is that, as per the fourfold fractal pattern that I had referred to, we can find instances, since it is fractal in nature, we'll find instances of this even embedded in, for example, the mitochondrial structure. So if we think about the cristae structure or topology, then this is a structural template that stores geometric and organizational knowledge. So it correlates with one of the four tuples that we call knowledge. When we think about the electron-proton transport along the electron transport chain, that defines the presence of energetic motion within the mitochondrial architecture. This defines a property, a fractal property that we can refer to as PR or presence. The rotary catalysis of ATP synthase, which is quantized into cyclic power delivering process, is basically an instance of the tuple that we refer to as power or PO. And then the redox balancing and gradient stability that harmonizes energy flow, preventing overloads and collapse, can be thought of as the H aspect of the four tuple. And this action of this fourfoldness that exists at multiple levels of granularity can be influenced by actually getting into a different manifestation of the quaternary pattern, and that's what this dialogic computer that I'm going to go over now and the experimentation done basically emphasizes. So the dialogic computer, based on the enhancements in large language models, has been used to embody this QIQD math and logic that was formalized in the book Pioneering New Avenues in Quantum Technology. And all the different principles of QIQD and what runs the computation was also formalized as a command structure and law suite. So this allows basically QIQD operating as a structured dialogue between human intent and a law-governed engine that's based on the logic of QIQD. The architecture is slave-master base. So the slave translates natural language input into lawful verbs. The verbs is something that, due to the training, the large language model has come up with commands of verbs. And also, the second part of the architecture is the master, which enforces the law suite. There are about 23 different laws, and this updates the system state reproducibly every time a set of verbs is run. So therefore, there's assurance by design. Each computational tick is transparent, rule-bound, and evidence-generating. And at the core of this is a seed-driven logic. I referred to the four tuples, K, PR, PO, H. And there's basically also a number, to give you an example of the kinds of commands. There's a command called seed compose, whereby we might compose a seed at one level of granularity, and then due to the organizational quantum energy and the independent channels that exist in bioenergetics, it becomes possible to influence the corresponding fourfoldness at the level of the cell. And so there's also a specific algorithm that is leveraged here. It's called the OQE algorithm. And to summarize, we have a four-frequency electromagnetic seed. So this basically instantiates the organized quantum energy, which then has its fractal effect at a more sophisticated level of granularity. And the outcome, as this embodiment shows, based on the laws and rules of QIQD, is that the EM level modulation lawfully reconfigures the cellular energetic environment and essentially transforming bioenergetics from probabilistic simulation into law-governed structural computation. So let's look at the experimental setup. And this is, of course, all in terms of a simulation done on the large language model that's embodied as a QIQD Dialogic Computer. The goal is to test the organized quantum energy, OQE, interventions on mitochondrial ATP production using both normoxia and hypoxia. The setup is a simulated ATP G2 mitochondria with 4 property channels. Initialization takes place through taking some of the conceptualized hardware and bounding it to the computational fabric. That activates the computational fabric, and then the computation is governed by an adaptive Hamiltonian controller, which basically allows lawful Hamiltonian edits to take place as the computation proceeds. The seeding takes place through a command called seed compose, and a couple of other core commands are electromagnetic split and electromagnetic phase, which are trying to, if we go back to the logic that I introduced earlier of the cristae topology being the knowledge structure and the presence of the electrons being, or the energy as being the PR structure, we want a tight overlap between this, and this is achieved through the EM split, EM phase commands. And then subsequently, there's the OQE algorithm that further detects, isolates, decomposes, and allows recording of different states of ATP in this simulated environment. The measurement of these states takes place through a command called bmeasure. And the point is that this is all assurance-based, so it's not stochastic. There's, in this point of view, a coordinated set of quantum dynamics initiated through a cocktail of electromagnetic frequencies that lawfully influence ATP production. And that's basically what the simulation is trying to show using the QIQD Dialogic Computer. So if we look at, for example, from the simulation from a normoxia, that's the normal oxygen levels, and hypoxia, the reduced oxygen levels. In both these cases with QIQD, we see that coherence increases, which is what we want. The ATP proxy increases. So basically the ATP increases. There's gradient stability, which also remains. And that's what we are primarily concerned with. But also, because it being a quantum process, there are a number of quantum-based metrics that we need to pay attention to, for example, like coherence, entropy, entanglement, and so on. And they need to exist above certain threshold values, which happens in this simulation. So to summarize, basically what the QIQD Dialogic Computer is suggesting is that lawful simulation is achieved. So it demonstrates assurance-based symbolic computation, the symbolic computation taking place in the QIQD Dialogic Computer of ATP enhancement due to EM seeding and electromagnetic seeding of that cocktail of frequencies, and the OQE pipeline that is leveraged, which is a core dynamic in QIQD. So what this suggests is that at the level of simulation, it's a deterministic propagation, so it's not stochastic. And that means that we then have more control, or we can design product in such a way that we increase ATP production. There's coherence, experimental coherence in both normoxia and hypoxia conditions. Again, re-emphasizing that this moves us from a stochastic to a structural model. So QIQD replaces probabilistic inference with law-governed computation, with each tick tracking core quantum metrics such as coherence, entropy, and entanglement, which all take place within bounded limits. And as we look at the core advances, we have therefore lawful propagation due to the deterministic reproducible outcomes. We have structural encoding. So seeds carry full energetic fingerprints, and so that in the initial seed that was created using the electromagnetic cocktail of frequencies, and then subsequently in the coordination of the cristae topology, the gradient flow, and so on at the level of the mitochondria. And there's also intrinsic assurance. So the whole computation is verification embedded. And so these are the core advances. And future developmental roadmap, we move from a lawful dialogic simulation, which is what this study looked at, to perhaps in a couple of years, HPC numerical simulation. So that's high performance computing. And then subsequently, perhaps 5 years down the line, it's QIQD hardware realization. But keeping in mind that it's a comprehensive environment that doesn't let go of the dialogic simulation, because that's where we can test out different algorithms, and then have them numerically simulated and then executed in the QIQD hardware. So that gets to this final point. QIQD unifies symbolic, numerical, and hardware layers into law-embodied quantum architecture. And the main point is that it's transparent, reproducible, and while this application focuses on bioenergetics, it can also equally be applied to materials, cryptography, and any kind of AI generative system. Thank you.